the blackened skies above the Pacific Ocean, on May 10, 1945, two American pilots found themselves trapped in a deadly game of cat and mouse 35,000 feet above the churning waves. What happened next would defy every rule of aerial combat and forever cement the legend of the most feared fighter aircraft of the World War II. But this is not just a story of triumph. It is a tale of engineering brilliance born from deadly compromise, of pilots who paid the ultimate price for imperfection, and of a machine so lethal that even its own side called it the Ensign Eliminator. The Vought F4U. Corsair was not merely an aircraft. It was a weapon of psychological warfare, its distinctive whistle striking terror into the hearts of Japanese soldiers across the Pacific. Yet behind its fearsome reputation lay a dark secret, a fundamental design flaw that would kill more American pilots than enemy fire ever could. This is the untold story of how one aircraft changed the course of history while nearly destroying the men brave enough to fly it. Our journey begins not in the heat of battle, but in the sterile drawing rooms of Chance Vought Aircraft Corporation in East Hartford, Connecticut, where in 1938, a brilliant but troubled design team faced an impossible challenge. The United States Navy had issued a seemingly simple request: build the fastest, most powerful single-engine fighter in the world. What they received instead was a machine that would redefine the very nature of aerial warfare and claim the lives of countless American heroes in the process. Chief Engineer Rex Beisel understood that conventional thinking would never produce the revolutionary aircraft the Navy demanded. The Japanese Zero dominated Pacific skies with its superior maneuverability, while German fighters terrorized Europe with their advanced engineering. America needed something entirely different, something that could match the enemy's best while delivering devastating firepower at unprecedented speeds. The solution lay in the largest, most powerful engine available, the 18-cylinder Pratt & Whitney R2800 double wasp radial engine, capable of producing 2,000 horsepower. But power came with a terrible price. To harness the full potential of this massive engine, engineers required an equally massive propeller, 13 feet 4 inches of spinning death that could slice through air like a scythe through wheat. This enormous propeller created an immediate and deadly problem. How could an aircraft carrier-based fighter accommodate such a massive blade without using landing gear so long it would snap under the violent impact of carrier landings? The answer came from Beisel himself during a tense engineering meeting in his cluttered office. As his team struggled with conflicting requirements, short, strong landing gear versus adequate propeller clearance, Beisel proposed something that had never been attempted on a production fighter. Instead of mounting the wings straight across the fuselage, they would bend them downward near the fuselage, then angle them upward toward the tips. This inverted gull wing design would allow the landing gear to be mounted at the lowest point of the bend, keeping it short and strong while providing the necessary clearance for that massive propeller. The solution was elegant, but it came with hidden consequences that would not become apparent until pilots began dying in the aircraft. The inverted gull wing, while aerodynamically efficient, created unequal airflow over the two wings during slow-speed flight. This meant that during the critical moments of landing, when pilots were most vulnerable, the left wing would lose lift before the right wing, sending the aircraft into a deadly snap roll just feet above the deck of an aircraft carrier. On May 29, 1940, test pilot Lyman Bullard climbed into the cockpit of the prototype F4U-1 for its maiden flight. As he pushed the throttle forward and felt the raw power of the double wasp engine surge through the airframe, he had no idea he was about to make history. The aircraft lifted off from Bridgeport Municipal Airport and immediately demonstrated capabilities that seemed impossible. During subsequent testing, the prototype would achieve a ground speed of 405 miles per hour between Stratford and Hartford, Connecticut, making it the first American single-engine fighter to exceed 400 miles per hour. But speed was only part of the Corsair's deadly arsenal. The aircraft's streamlined fuselage housed 650 caliber Browning machine guns, each fed by nearly 400 rounds of ammunition. This gave pilots almost 30 seconds of continuous firepower, enough to tear apart any enemy aircraft, unfortunate enough to find itself in the Corsair's gun sight. The combination of unprecedented speed and devastating firepower promised to revolutionize air combat. But first, the aircraft would have to survive its own design flaws. Production began in earnest after the Navy placed its initial order for 584 aircraft on June 30, 1941. The first production, F4U-1, made its maiden flight on June 24, 1942. But by then, America was already 6 months into a war that would test every aspect of the Corsair's design. The aircraft that rolled off the production line was significantly different from Bullard's prototype, with the cockpit moved 3 feet further back to accommodate an additional fuel tank. This modification would prove to be another deadly compromise. Moving the cockpit rearward created what pilots would come to call the hose nose problem. The 13-foot propeller and extended fuselage meant that pilots sat far behind the aircraft's center of gravity, with an enormous engine blocking their forward view during critical phases of flight. During carrier approaches, when precise control was essential, pilots found themselves essentially flying blind, relying on peripheral vision and instinct to guide their aircraft onto the narrow deck of a moving ship. The Corsair's problems became tragically apparent during its initial carrier qualification trials in the fall of 1942. Lieutenant Commander Sam Porter, tasked with testing the fighter's carrier suitability aboard the escort carrier USS Sangamon, found himself fighting for his life during what should have been routine landing practice. The aircraft's long nose made it nearly impossible to see the landing signal officer, while the stiff landing gear caused the aircraft to bounce violently off the deck, often clearing the arresting wires entirely. But it was the aircraft's stall characteristics that nearly killed Porter and countless others. As the Corsair approached the deck at low speed, the massive propeller's slipstream created unequal airflow over the wings. Without warning, the left wing would suddenly lose lift, rolling the aircraft violently to port just moments before touchdown. Pilots instinctively added power to recover, but the enormous torque from the R2800 engine only made the situation worse, often flipping the aircraft completely inverted just feet above the waves. After 4 terrifying landings, Porter declared the Corsair unsuitable for carrier operations, effectively ending its naval career before it had truly begun. The Navy, desperate for capable fighters, relegated the Corsair to land-based Marine squadrons while continuing to develop the more docile Grumman F-6F Hellcat for carrier duty. This decision would prove to be a blessing in disguise, as Marine pilots, operating from longer runways with more forgiving landing characteristics, could focus on exploiting the Corsair's devastating combat capabilities. The aircraft's distinctive sound became its calling card long before its first combat mission. As Corsairs dove at high speed, air rushing through the wing-mounted oil cooler intakes created a haunting, high-pitched whistle that could be heard for miles. This sound, combined with the aircraft's bent-wing silhouette, made it instantly recognizable to friend and foe alike. Japanese soldiers would soon learn to fear that whistle, knowing it meant death was diving toward them at over 400 miles per hour. Marine Fighting Squadron 1. 2-4 became the first unit to take Corsairs into combat when 12 aircraft arrived at Henderson Field on Guadalcanal on February 12, 1943. 2 days later, they would encounter the enemy for the first time during an escort mission for consolidated B-4Y Liberator bombers attacking Japanese positions at Kahili. The mission would become known as the St. Valentine's Day Massacre, but not for the reasons American planners had hoped. Japanese Zero fighters, forewarned of the incoming raid, were waiting in the clear Pacific skies. Despite the Corsair's superior speed and firepower, inexperienced American pilots found themselves outmaneuvered by veterans who understood their aircraft's limitations. The Americans lost 2 Corsairs, 2 Liberators, 4 P-38s, and 2 P-40s, while shooting down only a single Zero. It was a sobering introduction to combat for the bent-wing bird. But Marine pilots learned quickly, and by the summer of 1943, Corsairs were beginning to dominate Pacific skies. The aircraft's superior speed allowed pilots to control the terms of engagement, diving on enemy formations and climbing away before slower Japanese fighters could respond. Its rugged construction meant it could absorb punishment that would destroy lighter aircraft, while its heavy armament could tear apart enemy planes with short, devastating bursts. The most famous Corsair squadron was Marine Fighting Squadron 214, better known as the Black Sheep. Formed in August 1943 under the command of Major Gregory "Pappy" Boyington, the squadron consisted of replacement pilots and misfits from other units. Despite, or perhaps because of, their unconventional nature, the Black Sheep would become one of the highest-scoring fighter squadrons in the Pacific, shooting down 97 Japanese aircraft and damaging another 103 during their 2 combat tours. Boyington himself embodied the contradictions of the Corsair program. A former Flying Tiger with the American Volunteer Group in China, he had returned to Marine service with a reputation for both exceptional flying skills and excessive drinking. Like the aircraft he flew, Boyington was brilliant but flawed, capable of extraordinary achievements while harboring self-destructive tendencies. On January 3, 1944, while leading a fighter sweep over the Japanese stronghold at Rabaul, Boyington was shot down and captured after claiming his 26th and 27th aerial victories. While Boyington languished in Japanese prison camps, other Corsair pilots were pushing the boundaries of what their aircraft could accomplish. The fighter-bomber variant, capable of carrying 2,000 pounds of bombs or 8 5-inch rockets, began pioneering close air support tactics that would become standard doctrine for decades to come. Marine infantry dubbed the Corsair the sweetheart of the Marianas and the angel of Okinawa for its precise and devastating attacks on enemy positions. But perhaps no single incident better exemplifies the Corsair's deadly capabilities and its pilots' incredible courage than the encounter that occurred on May 10, 1945, high above the Pacific near Okinawa. Captain Kenneth Reusser and First Lieutenant Robert Klingman were conducting a routine combat air patrol when they spotted vapor trails from 2 Japanese reconnaissance aircraft at 35,000 feet. Racing to intercept, the 2 Marines climbed to the very limits of their aircraft's performance envelope, their supercharged engines straining in the thin air. At 38,000 feet, 3,000 feet above the Corsair's rated service ceiling, Klingman found himself directly behind a Japanese Kawasaki Ka-45 NIC reconnaissance aircraft. The extreme altitude had frozen his machine gun solid, leaving him with no conventional means of attack. Faced with the prospect of watching the enemy escape after an hour-and-a-half chase, Klingman made a decision that defied every rule of aerial combat. Using his propeller as a weapon, Klingman deliberately rammed the Japanese aircraft's tail section. The first strike severed part of the rudder, but the NIC continued flying level. A second attack destroyed the rear gunner's position, flinging both man and machine into the void. On his third and final strike, Klingman's spinning propeller blades cut through the NIC's tail section entirely, sending both aircraft into uncontrolled spins toward the ocean 38,000 feet below. Klingman managed to regain control of his violently shaking Corsair after falling 1,000 feet, but his propeller was destroyed, with 6 inches missing from one blade, and the other 2 bent back almost to the engine cowling. Pieces of the Japanese aircraft were embedded in his engine cowling, while bullet holes from the NIC's defensive fire peppered his right wing. Somehow, he managed to nurse his damaged fighter back to Kadena Airfield, where he executed a dead-stick landing that would have challenged even the most experienced test pilot. Standing on his aircraft's wing. After the landing, Klingman surveyed the damage with characteristic understatement, declaring in his Oklahoma drawl that it's a hell of a way to earn a buck. His actions that day earned him the Navy Cross and a place in aviation history as the only pilot ever to achieve an aerial victory using his propeller as a weapon. The incident also demonstrated the Corsair's incredible structural strength. Few aircraft could have survived such abuse and still brought their pilot home safely. By war's end, Corsairs had compiled one of the most impressive combat records in aviation history. Flying from both land bases and aircraft carriers, once solutions were found for the carrier landing problems, Corsairs shot down 2,140 Japanese aircraft, while losing only 189 of their own, achieving an extraordinary 11-to-1 kill ratio. This success came despite the aircraft's early problems and the heavy price paid during its development and early service. The Corsair's effectiveness extended far beyond air-to-air combat. Operating as fighter bombers, Corsairs dropped more than 15,500 tons of ordnance during World War II, accounting for roughly 70% of all bombs delivered by American fighters in the Pacific. Their ability to carry heavy loads while maintaining fighter performance made them invaluable for close air support missions, particularly during the bloody island hopping campaigns that characterized the latter stages of the Pacific War. Notable figures contributed to the Corsair's ground attack reputation, including Charles Lindbergh, who flew combat missions with Marine Air Group 31 in 1944, as a civilian consultant helping to extend the Corsair's range and payload capabilities. Lindbergh demonstrated that the fighter could carry bomb loads previously thought impossible, opening new tactical possibilities for Marine commanders. The Corsair's superior performance compared to its contemporaries was unmistakable. While the F-6F Hellcat proved easier to fly and more suitable for carrier operations, the Corsair was significantly faster, with early variants reaching 417 miles per hour compared to the Hellcat's 380. The Corsair was only 13 miles per hour, slower than the massive Republic P-47 Thunderbolt, despite being a much lighter aircraft designed for carrier operations. Production of the Corsair continued long after World War II ended, making it the last American piston engine fighter in production and the longest produced American fighter of its type. From the first prototype delivery to the Navy in 1940 to final delivery to the French in 1953, 12,571 F4U Corsairs were manufactured in 16 separate models. This 13-year production run remains unmatched by any American piston engine fighter. The Korean War provided the Corsair with a second chance to prove its worth in combat. Operating primarily as a close air support aircraft, Corsairs flew from both carriers and land bases in support of United Nations ground forces. The aircraft's ability to operate in frigid weather and deliver precision strikes made it invaluable during the brutal mountain warfare that characterized much of the Korean conflict. In one of the most remarkable achievements of the jet age, Marine Captain Jesse Fulmar became the first pilot to shoot down a jet aircraft while flying a propeller-driven fighter when he destroyed a MiG-15 jet, while flying a Corsair from Marine Attack Squadron 312 on September 10, 1952. This victory demonstrated that even in the age of jets, the right pilot and the right aircraft could still achieve the impossible. The Corsair's combat career extended far beyond American service. The Royal Navy operated Corsairs from aircraft carriers in the Pacific, developing innovative landing techniques that eventually solved many of the carrier operation problems that had plagued early American efforts. French forces used Corsairs in Indochina and Algeria, while other nations continued operating the type well into the 1960s. The aircraft's final combat mission came during the so-called Football War of 1969 between El Salvador and Honduras. This brief but intense conflict saw Corsairs and P-51 Mustangs engage in the last dogfights between piston engine fighters, with Honduran Captain Fernando Soto achieving 3 aerial victories while flying his F4U-5 NL Corsair. It was a fitting end to the combat career of an aircraft that had dominated skies for over 2 decades. The engineering challenges that created the Corsair's distinctive appearance also contributed to its legendary status. The inverted gull wing that solved the propeller clearance problem became an instantly recognizable silhouette, while the massive R2-800 engine provided both the power and the distinctive sound that made the aircraft famous. Even today, the whistle of a diving Corsair can send chills down the spine of anyone who understands its historical significance. Yet the Corsair's legacy is not without its dark chapters. The aircraft's early problems killed numerous pilots during training and combat operations, earning it the grim nickname Ensign Eliminator among Navy aviators. The stall strip modification that finally solved the asymmetric stall problem, a simple 6-inch triangular piece of wood or metal attached to the right wing's leading edge, came too late to save many young pilots who paid for the aircraft's design flaws with their lives. The human cost of the Corsair program extended beyond combat losses. Test pilots, production pilots, and training instructors all faced the daily reality of flying an aircraft that could kill them without warning. The high accident rate during training meant that for every ace who achieved glory in combat, several others died, learning to master the bent-wing bird's unforgiving characteristics. Despite these tragedies, the Corsair's impact on aviation history cannot be overstated. Its advanced engineering influenced fighter design for decades, while its combat record proved that properly designed carrier aircraft could match or exceed the performance of their land-based counterparts. The lessons learned during the Corsair's development and service would inform American naval aviation doctrine well into the jet age. The aircraft's influence extended beyond military applications. The engineering solutions developed for the Corsair, from its advanced supercharger systems to its innovative wing design, found applications in civilian aircraft and industrial machinery. The manufacturing techniques pioneered during its production helped establish the foundation for America's post-war aerospace industry. Today, fewer than 40 Corsairs remain airworthy worldwide, precious reminders of an era when young men climbed into machines that were as likely to kill them as the enemy they faced. Each surviving aircraft represents not just a triumph of engineering, but a memorial to the hundreds of pilots who died mastering its deadly characteristics and the thousands who flew it into combat against overwhelming odds. The Corsair's story is ultimately one of contradictions, a machine of incredible beauty and devastating ugliness, of technological triumph and human tragedy, of salvation and destruction. It represents the very best and worst of wartime innovation, where brilliant engineering solutions came at the cost of human lives, and where the pressure to produce weapons capable of winning a global war sometimes overshadowed the safety of the men who would use them. In the end, the Vought F4U Corsair succeeded in its primary mission. It helped win World War II and establish American air superiority in the Pacific. But that victory came at a price measured not just in enemy aircraft destroyed or strategic objectives achieved, but in the lives of the young Americans who climbed into its cockpit, knowing they might not return. Their sacrifice, combined with the genius of the engineers who created this remarkable machine, forged a legend that continues to inspire aviation enthusiasts and military historians more than 80 years after its first flight. The whistle of death that once struck terror into enemy hearts now serves as a haunting reminder of a time when the fate of the free world rested on the wings of aircraft, like the Corsair, and the courage of the men who flew them. In an age of computer-controlled weapons and push-button warfare, the Corsair represents a more personal form of combat, where victory depended on the skill, courage, and determination of individual pilots willing to risk everything for their country and their comrades. This is the true legacy of the Whistling Death, not just an aircraft, but a symbol of American ingenuity, determination, and sacrifice during humanity's darkest hour, It stands as proof that even the most advanced technology is meaningless without the human spirit to guide it, and that sometimes victory requires not just superior weapons, but superior courage to use them effectively.